scaling agents is harder than building them. Do you agree or disagree? 3, 2, 1, vote. Ooh, little mixed bag. All right, why? Allegra, you were the odd one out.
I think building agents is really hard.
Welcome to Human in the Loop, a series where we discuss what it takes to build and deploy real-world systems for the enterprise.
Hey everyone, welcome back to Human in the Loop. I'm Felix Su.
I'm Allegra Larche.
And I'm Mihir Pandya.
Today we're going to be talking about the state of agents and the challenges that come with. But first, let's check in with the news.
Did you guys see that MIT found that 95% of Gen AI pilots fail in enterprises? Is that a big deal for enterprises? What do you think?
I saw that. It was a little bit of a clickbaity headline, but I mean, I feel like that study itself has an interesting common denominator effect because it's so easy to try a bunch of new things. So you will have a large denominator, but because you try a bunch of new things, they may fail, they may not fail. And so that's my take on that piece.
Yeah. I think realistically speaking, enterprises, I like to think about things in phases. And so every single year you got to think about it takes a long time for an enterprise to get everything together and release things to production. And so you're really having a little bit of a delayed response to some of the initial pilots that you're trying, right? Connecting things to your data, trying them out. So a lot of the things that you're going to release after 2 years of work are going to be, let's try connecting to this data source. Let's try building a chatbot, right? They're not going to be your most creative and inspired ideas on what's next and most informed after you've learned through trial. So I think we're pretty early. I think there's going to be in another year or two, you're going to see a lot of agents come out. We're talking about that. That's going to be more impactful. But now I think, that definitely has a lot of common denominator problems.
Yeah, I think the thing that's interesting to me there is that people thought that Gen AI is going to give you this amazing value overnight. And that part doesn't seem to be true. And that is something that I do see in various use cases because it's not like models are getting amazing and very custom specific things that matter for specific companies or organizations. There is some extra layer that needs to exist that bridges the gap between where the models are getting better and what people actually need.
Yeah.
And I think there's operational changes that need to happen to bridge the gap in addition to just the technology being useful. And I think that takes longer to achieve.
It's non-trivial.
Yeah.
And if I may ask, I think both of you kind of are leading our forward deployed efforts now. I think, hopefully it's easy to see now that some of these things are harder than they seem. I think customers have this I guess this assumption that it just works. It's magic. The AI will if I can answer, then it can answer, right? But there's a ton of wiring and plumbing that needs to go underneath. What has your guys' experience been so far? What have your engineers been telling you that's hard about these problems?
Yeah, I mean, I think because the open source technology is evolved so quickly and there's so many compelling demos, it really feels like the FOMO effect is real, where there's something out there that we should be building or people can easily build prototypes, but then where we've seen difficulty is trying to get them to production. And really when it comes to getting things to production, it's trying to get your prototype to work with your production data systems or your production compute runtime environments. And those parts are complex and bespoke for each organization. And I mean, organizations don't really hire for those specific things. That's not what their core competency is. And so that's exactly where a lot of our engineers are seeing that they are spending time to come in there and bring these prototypes to production.
There's also a big gap between prototype delivering on functionality and a production system being reliable enough for an enterprise solution. I think the reliability piece is maybe what we're going to get into in a little bit, but the oversight and management and building agentic systems that are deterministic enough for solving real enterprise use cases is kind of the hard part.
Yeah, and I think there's actually a technical nuance here, which is when you try a generic LLM, you feel a lot of the difficulties are smoothed out. Because what happens is they do training over large amounts of data, right? And so that is smoothed out because you have thousands, probably millions of GPU hours being spent and a ton of data being spent to smooth those edges out. So you have an expectation that it's super smooth. But now when you connect it to like live data that's not been trained on, it's not going to be that smooth because you're doing like live adjustments, and so there's gaps between your knowledge. Like we do like an engagement with one customer, and like the last mile delivery is all about, oh, I thought that you had access to this data. Why is it not saying that? Why is ChatGPT be able to do it on last year's articles? Well, this year's articles are being fetched with some queries. Maybe the query has some gaps in between, or maybe there's non-determinism in writing a query. And so you encounter these like things that you expect to be smooth, but in reality, connecting live data there are gaps in it, right? And it's our job to make it smooth. But that last mile delivery is that, it's tough to educate people like, oh, these are the ways that you need to do it properly in order to get it to like a production level. So I think that scares a lot of people, which is why, these 95% of pilots failing is just like that feeling that at the end you get a little bit panicky, that it's just it's not working the way you expect it, and you don't kind of grit and grind, try to solve that problem. A lot of people like exit out and say maybe it's not worth it to do it at all.
So in response to this study, Better Up Labs and Stanford Social Media Lab released a study on something they're terming AI work slop, which is AI-generated content that looks good but lacks substance. And so the issue is that it creates this illusion of progress. So rather than saving time, which is what I think a lot of our Gen AI solutions are supposed to do, it just creates more work for colleagues to like clean up these large documents and this content that's not actually useful. Is this something you've seen? Is this something that we should be concerned about? What are your takes on this?
That's so interesting, but yeah, go ahead.
I was going to say, I think this is something that we are actively trying to fight right now. I think the interesting piece about this article is that if you think about like what is actually consumable by an AI system, it's not 100 pages of documents. You actually want to like think about compressing the information that you're sending to an AI system into something that can like fit into a reasonable context for that system to consume. That's probably the same thing that humans need. And for some reason, we've just moved in the opposite direction. Like if we actually want these systems to be really effective, we actually need to compress the information a little bit more, not necessarily like explode it into a bunch of generic nonsense.
Yeah. I think like it's really easy to like use AI and then summarize things and hand them off. But what happens in that situation is that everyone just like does a lot of telephone. There's a lot of telephone and compression and telephone and compression. And what happens is you lose a lot of like the meat of what you're trying to move towards, right? Because you're just doing a lot of synthesis. And actually when you synthesize something that's meaningful into something else, and then someone synthesizes from that, and then you lose a lot of that stuff. And so I think it's really, really important for us to, and we're going to talk about this later, but like always check back in with humans. You need to like reduce your error rates. You need to not like just have AI talk to AI, synthesize AI stuff. I think a lot of that stuff becomes a lot of jumbled up garbage. So realistically, I think you just have to build AI that's like very targeted in what it's trying to solve, not use it for expansion. I think expansion is noise, and reduction is like what Allegra's saying is like you want to compress into something meaningful. So, I think a lot of the tools that you see here that people use like effectively are things that, like, let's take code generation, for example, gets like, yes, there's expansion in generating code, and then there's compression in making sure it passes your tests and making sure it passes your PR reviews, right? And so you need to have like a check-in where you say like, this is useful at a certain point and not just, generating things.
I think that's why it's called slop, where it's just like generated stuff that's completely unchecked, unverified, and just put out in the open. And I think like when it comes to actually using them for load-bearing actual use cases, you need that like feedback loop to make sure that what is being output by your AI systems is verifiable and is something that is actually useful.
Yeah, like a good example of slop is like, let's say one of our engineers or product managers writes a PRD, and you're like, oh, let me just generate the PRD.
Yeah.
But the problem is, well, okay, the AI is going and making some assumptions about, like unfounded assumptions about how to make this reasonable design, but not based on this product manager, the software engineer's understanding of what you're trying to do. There's like 10,000 ways to solve a problem, but you have to solve it based on like what makes sense for your business, what makes sense in the context of all the other technology that you've built. Maybe you can say like, oh, we're going to make actually like a suboptimal decision because we don't want to cause a migration problem or something like that. That context lost in translation can cause slop issues because the reviewers don't know that was AI generated and not based on real information from people. So you just have to be a little bit careful. And I think like having worked with a lot, like I actually think I can tell if something is AI generated. I used to think when in the beginning, I remember early days when I was working on scale, I made this like kind of dumb comment that, oh, aren't these AI things like basically Turing complete now or pass the Turing test, sorry. And I got this like kind of snarky answer like, oh, no, it's not. And I realized this person, that was at scale before, had seen a ton of AI, way more AI responses than I have. And now that I've seen that amount, I'm like, wow, like, yes, you really can tell this is Gemini, this is OpenAI, this is like, you can read it. And so like, honestly, having that filter also is helpful in determining slop or not.
Great. Well, that's all for the news. Let's go ahead and get into the main topic. Felix, what are we talking about today?
Yeah, so we wanted to talk a lot about agents because I think that's the direction that a lot of people are moving towards. I remember Jason, our CEO, said that he was talking to a customer, and then we were talking about connecting to data and all this sort of stuff. And they were like tuning in, tuning out for about 20 minutes, and then he's like, "Yeah, we built these agentic things," and they were like, "Agents." Like, oh, why don't you just say that from the beginning? Like, agents is what we're interested in because there's kind of like a big gap between like context engineering, which normal engineers understand, and agentic engineering, which is something that's more of an applied AI or MLE focus, right? So I'm curious kind of what your guys' take on the current state of agents. There's some things like context engineering, data practices that we want to talk about. So maybe, Allegra, we start with context engineering, context route. What is your opinion on some of the problems that we face today with this?
Yeah, I think this is kind of what we've been speaking through already, but context engineering seems to be kind of the hot problem. And I don't think that this is really a solved problem right now. It is already difficult to context engineer a prompt for a single agent executing on a single task. I think where it gets really challenging is multi-agent systems where you're trying to figure out what is the correct context to give each of the sub-agents so that they have enough context about how the system is working as a whole, but they're also able to stay focused on their individual task that they're executing on. I don't have an answer here, but curious if we have any opinions there.
Yeah, I mean, I guess the reason context engineering exists is because we know that like agents don't perform well with infinite information. And so you kind of have to figure out what information you have to give it and how to package it so that the agent itself can give you a meaningful output. And that part is context engineering. And that's the challenge because figuring out what the output needs to be, figuring out what is good quality output is so subjective. Like even in our like Gen AI business, when we work with the frontier labs, the first question we ask them is, what does quality mean for you? And we come to a shared definition of quality. And everything else about generating data is downstream of that. And so context engineering is, to me, is a problem that it has to exist because these systems, like by definition, cannot handle infinite information.
Yeah, and I think it's actually pretty interesting. Like I feel like when you try to do context engineering, you create problems for yourself too. Because let's take, for example, like you were talking about like multi-agent systems. The reason why you build a multi-agent system in most scenarios is because you feel like you're trying to solve a context problem. Because otherwise you would just give it to one agent, and if that agent did deep research and stuff like that, you're like, why don't I just have one agent do the whole thing? But the problem is maybe that research is just one step of a larger workflow, and it's filled with a bunch of research steps that maybe some research needs to be discarded, some research needs to be considered. So maybe you should have a higher level orchestrator. But now you have this problem where, what if I have one orchestrator and I have a deep research agent and I have a Slack agent? And I want those two things to kind of like, or maybe actually, you know what, I'll give a better example. Two deep research agents, one does research about one thing, one does research about another thing. So you hand off a message to each of them, and all of a sudden, they go off and start independently doing work. But now they start, because they are agentic, going a little bit past the boundary of what they were asked, because they're agents, right? They can now overlap in what they're doing, but they don't know about each other, right? And so now they overlap, and they both send back overlapping information back to the orchestrator. Now the orchestrator gets confused, right? And so I'm curious kind of like how you guys think about these type of problems, what's Scale's approach to solving these things. I think it's like totally an unsolved problem and usually solved in a customized way for each use case.
I do think that there's, like specifically with that example, at least if you have two agents doing deep research, like that's still a read operation. They're both kind of reading in parallel, and yes, they could be reading the same information and maybe giving overlapping output, but the risk is much lower compared to if you have two agents that are like writing and there's some dependency between what one agent is writing versus what another agent is writing. I think that's where it starts to get kind of complicated. Like you need to think more about kind of, is there some sort of oversight layer or orchestration layer that they need to be talking back to and agreeing with before they can execute on those actions? Yeah, that part is, I think, where it gets kind of complicated.
Yeah.
Yeah, I think at least for deep research or like agents that run for a longer time, the common architecture that I'm seeing is that, it comes back to like first principles, where an agent needs to like look at the problem, understand the problem, make a plan on how it's going to tackle the problem, and then execute the plan. And as the plan is executed, it learns more information. It keeps track of that, maintains a to-do list of what it needs to do next, and then continues until it finally has an answer that satisfies the initial request. So to do all those things, you also need some infra piece that you can sort of connect to, where you can treat that as a scratch space, where you can maintain and update your to-do list, where you can maintain and update your plan, where you can share your plan with other agents so that they know what work you have done so far. That infra layer, it becomes very critical to become a more horizontal use case.
Yeah. I think it's funny. Like, I think the article that we're gonna have to rediscuss in a couple months is like 95% of multi-agent systems are useless, and you should go back to single agents. But I think it's like this is a thing that happens. Like, people overthink. I tried this once, and like it just doesn't work. And it's like that's just like not how you develop. Like there's like experimental aspects of it. It's not easy. You have to design a way around it. Like, there's something pretty interesting about the multi-agent system where I think a lot of it is a product decision, has nothing to do with AI, which is like, if you have a multi-agent system, do you show a user everything that's happening in the system, or do you only show the user what's happening between it and its orchestrator? And, I always say there's like two ways to do it. One, you show them everything, or one, you don't show them anything that's happening in the sub-agent. But if you show them everything, but I only am able to talk to the orchestrator, if the sub-agent didn't talk back to the orchestrator or send it back some information, then the orchestrator is going to be confused. It'll be like, what are you talking about? I'll rather say, you looked up this article, be like, I didn't look up this article, because it thinks it's sub-agent, and the sub-agent didn't tell it looked up the article, right? And so now it's confused. So then what if I don't send it all the information? Then, some things that are happening might get lost in translation. You might look up some things, and I'll be like, how did you have access to that, or whatever? And I'm confused now. So there's so much product massaging, good AI practices, content engineering. Like, you have to like make it work. You don't just try it. Like, that's not the way that these things work. And that's why you see like studies like this. People try things and they kind of like get panicked. Like, this is like AI and ML used to be like 5 years ago. We kind of forget like AI, ML, traditional machine learning is just pure experimentation. You get like PhDs to go in a room, 2 years, they do a research problem, they run like 50 experiments, they spend like millions of dollars, and then like one of those paths work. Do you know what I mean?
Yeah.
Like that, like we kind of forgot that was like how it works, And so, I think we don't want to overthink these things. Like, it takes time, takes effort. You got to get the right people.
Yeah, I think what's interesting about what you said is that like it's never a one-size-fits-all solution. You have to iterate, you have to try it out. And so that's where like the pieces you build around measuring the performance of this become more and more important, because the stronger and the more robust your layer is for evaluating your system, the more things you can try reliably. And I think that's why infra becomes such a critical piece for agents. So,
Yeah. Yeah, I want to talk a little bit about that, like, agentic infrastructure piece as well. I think everybody at this company knows that I'm very passionate about this subject, but I think, like, my main thing is that I think, like, the world's hardest problems take a lot of time. Like, like, deep research is not that big of a problem for me. It's a big problem for agents, and we focus on it a lot. But, like, realistically, like, yeah, I need to look some documents up. Okay, that's like a small problem for me. A big problem for me is, like, delivering on a customer account. There's a lot of human handoffs there, driving things forward. There's a lot of dead time between people not understanding, the difference between two documents. Where is this document? Where's that document? There's so much stuff there. And if you have an agent driving that forwards, I think that is super, super interesting. And there's so many, like, open-ended problems that are not being explored. For example, we had a customer who wants to decide if they, go somewhere to do, like, oil drilling or whether to manufacture a certain drug and what's the process to do that sort of stuff, right? And there's, like, it's a 6-week-long process. There's a ton of handoffs. So I think it's so crucial for us to build software and infrastructural things that orchestrate this sort of stuff, right? I mean, today, I think if you just take OpenAI agents, download it and try it, throw it on a server, that thing is not going to be able to orchestrate along or anything. That thing will die. Like, as soon as it has to, like, escalate to human, what happens? You have to, like, save your whole state, revive it. I mean, there's so much complexity in that. And I think super, super underappreciated area of, like, software and tech development that people aren't really seeing. I'm curious kind of, like, what your guys' thoughts are on that and where you think that scale is going to take its business in the future.
I feel like the name of this podcast is kind of relevant here because you really do need to think about humans in the loop as, like, a first-class citizen for designing an agent. And especially, I don't know that we need to fully replace all of these kind of clunky, like, handoffs between one team to another, but there is something to think about. Like, multiple people have different context, and you might need multiple people to do approvals for a particular action that an agent is taking, or there's some layer of human orchestration that needs to live on top of just the agentic orchestration that we probably need to think about as well.
yeah. I mean, I think the most important and difficult problems that you mentioned do not exist in isolation, and they are going to be messy problems. They're going to have some component that requires the new shiny Gen AI component. There's going to be something that will require a human in the loop. There's going to be something that will require a classic ML. There'll be something that will require a database. And so the reason in the infrastructure and the orchestration is so important is because that is the glue between all of these systems. And the more you invest in a glue that allows seamless communication between these pieces, the more you are likely to solve real-world problems. Like, thinking about what kind of a system should solve what kind of a problem is the entry point for orchestration, because you look at a problem, which is a messy problem, like, how do I reduce churn or how do I find anomalies? You divide that into smaller pieces. You then allocate each piece to the component that is optimized to solve that piece. You take the results and then you bring them back. So if you can build that glue across those various systems, then you're more and more likely to solve these problems. So that's how I think about these things.
Yeah, I like the way that you put it. I think, like, that glue is so important because, like, if you don't have a really, really good orchestration layer that can, reach into all these systems, which may take long portion of times, may pause for human escalation and all that sort of stuff, then you're basically reducing yourself to just, like, simple, like, oh, I just asked this thing and it's going to respond in 30 seconds. How many things in this, if we really want AI to be as transformational as it is, like, how many things do you think we can solve if we just, like, oh, it's like a thing that can respond to me in 30 seconds? It's, like, not that, like, the space of problems that is solving is pretty limited. And so I think the better the glue gets, the better the infrastructure gets, the more that you can do, the more powerful you'll see AI being. And I think, like, one thing, the reason I believe in agents so much is because I think that in a business, I've worked at several at this point, like, in a business, like, there are a few decisions that require some creativity and opinion. and then a bunch that don't. Like I look at a document, I'm like, yeah, like based on this paragraph, I should go send it to this person. Or like, oh, I look at these numbers, these like vendor statements come in, like I need to flag this, flag that, send it to a lawyer, send it to here. Like it's pretty standardized operations, right? And so if we can get agents in the loop on these standardized operations and be able to do harder and harder, longer running things, you will see AI enter another phase where people are starting to do like really hard business critical things. Even earlier this week, we were in like a business review, and and Jason was talking about like humans in the loop, and we're like, remember I said we should just take only deals that have humans in the loop because those are the ones that are most business critical. If you feel like you don't need a human in the loop, it's probably not important enough, for you. And so, like, I think this is a huge opportunity. I think, like, human-in-the-loop type things are going to be really critical for our business in the future. And so, it's important that we invest in it.
Where does data fit into this conversation?
I feel like you have some opinions here.
Okay, so my opinion on data is, like, there's two types, I think, major, right? One is enterprise data connected to elements. Like, that's kind of like a solved thing. I think we don't have to talk too much about that. It's just, like even enterprises that are late to adopt AI kind of know how to do it. There's a more interesting data, which is behavioral data. Okay, so when I talk to enterprises, I always say there's two types of data. There's the data that you've stored and the data that's in your head. And the data that's in your head is more like what your company was built on. Like why do consulting companies exist? Because they like built their brand on a way of doing something. And they created excellence from that, right? But what is the like? What is their process? Like you don't know. Like why is a bank different than another bank? Because they train their employees a certain way. They have a certain procedure, right? But nobody knows. No one writes it down. Like this is the procedure. You follow this exactly, right? So the way that we can get that data is to build AI agents that work alongside these people. And you get a lot of information about how do the users use these agents? What kind of decisions do they want to make? What are they unhappy about when the agents, go off the beaten path of what they're comfortable with working at their company, doing things their way? That data, storing that is going to make those AI agents really, really powerful. So I feel like we definitely need to have that hidden data, which is not captured yet.
I mean, I think traditionally, like when I think of data, I think of like who's the end user of that data. And like in classic distributed systems, we've built these mechanisms that allow us to handle like an insane amount of data, because that's ultimately you use that data to get some insights. And we've also built some compute systems that help us understand and analyze that data. And so what we've learned is that there are some use cases where the end user of data is computer systems, and then there's some use cases where the end user of data is AI or humans. And so the challenge that we're seeing in a lot of these organizations is that they have obviously been maintaining these mountains and mountains of historical data, but you need systems that are able to understand that, get insights, and then leverage them. And so being able to sort of marry these two use cases becomes super critical, where you want to build classic systems and computer systems that are able to get statistical information from large amounts of data. And then from that statistical information, you want to glue that with semantic information for a human to consume. And that is the shape of the problem that we are seeing over and over again in various like real world problems, as you mentioned. And so building something that is able to marry traditional computer systems and new AI systems is like the next challenge, in my opinion.
Yeah. Like there's a good example of this. Like if you take like inventory management, a good traditional machine learning statistical problem is inflow and outflow optimization, right? Mm-hmm. Obviously, you have a lot of data about what's going in, what's coming out. So you can build traditional machine learning to optimize for what to buy next, right? That's not a generative problem, right? It's probably going to be worse if you do. Okay, but what about outlier events that are coming in? Like it's really hot today, or there's a heat wave coming next week, or there's a sports game coming. Like you're probably going to stock water, you're going to stock drinks, right? Like, so you want to have some overrides based on semantic understanding of events that are happening, which is new information that's like small sample size and outlier, which so it doesn't fit well into the traditional statistical machine learning models, but still needs to be like fit into the system somehow, right? And so that could be fit in as override. So I definitely think there's like so much opportunity to augment traditional machine learning models and stuff like that, statistical things, with the generative aspects of the new AI today.
Yeah.
If you guys had to, just to wrap this up and this discussion up, if you had to each kind of give a piece of advice or a takeaway for an enterprise exec who's kind of facing some of these challenges, what are some of the things that you've talked to customers about or given advice to customers who are facing these issues?
The big one that I keep repeating to a bunch of execs is think about augmenting your star performer as opposed to replacing them. That is the biggest unlock you can get immediately. I think that is a way to think about AI systems. So that happens over and over again.
Yeah. I guess that's I feel like I would have said the same. Like start with a process that you already know can be improved, I guess, and start with like the MVP of what can improve that process, basically. I don't think you need to boil the ocean when you are like trying to adopt an entirely new technology and workflow.
Yeah.
Yeah, I mean, I have like there's two ways that I give recommendation, either like the visionary way or the tactical way. If you go like tactical, I think break off pieces of the problem that you feel like are measurable, that have like good outcomes, things like that, just because like you don't want to get in this rut where you like try too many experimental like theoretical things that are like too advanced without even having any thesis or hypothesis that that's going to work. For example, I think I liked kind of what we did with the telco. Like if we can reduce churn, like that's a measurable problem. Like you can get numbers from that. So it's easy for you to kind of see if there's benefit and see if you want to do further advancement, and you learn along the way what are the limitations and things like that, right? So I would encourage people to kind of like don't overthink things unless you have a reason to do that. Like you did experiments already, and you do feel like you know better. If it's your first attempt, you don't want to like run and then get scared. So that's an advice that I would give. And then one last advice that I would give is like, I think building AI is so difficult that like you shouldn't be spending any of your time doing like all this plumbing stuff. Like the plumbing stuff, like you should waste so much of your time. Like, okay, you build an AI agent, now you got to deploy it, now you got to manage it, you got to do secrets, you got to do the glue, you got to do the human escalation, you got like none of that stuff really matters. Like in this sprint of AI, you should be focusing on one thing and one thing only. How do you model your business logic to the highest quality possible? You know, that's like the only thing you should be. If you're doing anything else, then you're basically wasting your time on cycles that don't matter. So I do encourage people to kind of like keep that in the back of their minds. And if they ever feel like they're not advancing as fast as they should be, they should always take a look at that process.
Great. All right. So to close us out, we love to end on some hot takes here at Scale AI. So none of you have seen these before. Is that right?
That's right.
That is correct.
You didn't get my version of this. So what I'm going to do is I'm going to read out loud a hot take that is sourced from the internet. And then I'm going to have you vote. Do you agree with this take? Thumbs up. Or do you disagree with this take? Thumbs down. And I'm going to say 3, 2, 1, and then have you vote. Are you guys ready for your first hot take?
Ready?
Is this going to be slop?
It's
Okay.
Well, there's no AI. There's no AI here.
Okay. All right.
All right.
Great.
The very first hot take. Scaling agents is harder than building them. Scaling agents is harder than building them. Do you agree or disagree? 3, 2, 1, vote. Ooh, little mixed bag. All right, why? Allegra, you were the odd one out.
I think building agents is really hard.
What makes it hard?
I think like coming up with the right, I mean, a lot of the reasons that we talked about today, context engineering, orchestration of how agents talk to each other, deciding when to escalate to a human. Like, I don't even think that's a solved problem yet. I guess scaling would be the next problem, but Yeah,
Well, I think building a good agent is really hard. You didn't say good.
that's true.
Yeah.
That's true.
It could be any agent.
Yeah, that's true. Building agents is not that hard.
Yeah, I think
You were like this, right?
I was medium.
Yeah, you're on the fence.
The reason I'm on the fence is because, like, like, I think scaling agents is really hard because, like, you encounter a lot of unknown problems once you start to increase the amount of traffic that you're going to get and increase the scope of what an agent can do, because the surface area explodes. And I made this comment earlier, unlike traditional machine learning where you have millions of hours of GPU to like smooth over stuff, you just don't. I mean, what you have is somebody doing context engineering and bringing data to it and maybe fine-tuning a little bits and pieces there, but like you haven't smoothed over those things. And so you're kind of assuming that the assumptions you made while you were building are going to somehow apply. And not always is that the case. But the reason I'm in the middle is because now if I think about it, the whole reason that was hard in the first place is because it's hard to build agents. That's like the reason why it's hard is because, it like, like Allegra said, like I was talking to like Sam, I might have made this comment before in another episode or something, I forgot. But like, I think there's like two ways to like improve an agent at this point. It's like you context engineer it or you train it, right? Retrain the model. But at the end of the day, you're like, building a little bit of Lego blocks to try to like make this thing, kind of work. And you might have some gaps in between and all that. So I think building an agent just from the ground up is really, really hard. As soon as you scale it, you go back to why building an agent is really, really hard. So
Yeah, it's kind of
it's just like,
wheel.
exactly. As soon as
there's a
you
lot
get
of
to a
overlap.
milestone,
Yeah.
I see it like very much like step function style. Like you get it, you work really hard, you get it to like this milestone, you launch it, and you're like, oh, let's do something more with it, and then boom, you got to redo the building step again, and it's just as steep as it was before. So yeah, both very hard.
Yeah.
Good. Your second hot take is context rot is a bigger problem for agents than hallucinations. Context rot is a bigger problem for agents than hallucinations. All right. 3, 2, 1, vote. Ooh, some opposite here. Mihir, let's start with you this time. What's going through your head on this one?
So the main reason that this was my answer, or I disagree with this, is because I think there are ways to measure context rot, and it is really hard to measure hallucination. So I think both are hard problems, but at least one exists, and it's still hard to know whether the other one exists and when it's happening. And so for that reason, I'm saying context rot is the harder one. But yeah, that's my take.
Or you're saying hallucinations is the harder one.
Yeah, that's
Hallucinations are the
sorry.
harder one. Okay.
I got confused.
Yeah.
Yeah.
I think it's. Actually, yeah. If you put it like that, actually, that's like kind of interesting way to think about it. It's like one is a more solvable problem, and the other one is like less solvable and more about control. Yeah, if you put it that way, it's pretty interesting to think about. The reason I say context rot is more of a problem is just because I think that we just spend so much time dealing with like poor context and like bad information, and I feel like context engineering is the way that you guide the model, but also the way that you unguide the model the wrong way, right? You can bring way too much data into the context window, or you can bring the wrong data into the context window. And all of a sudden, like the model is doing something poor because you're like actively guiding it away from what you want. I'll give an example of this. Like we were building this agent that has access to the index of this digital media company, and the thing is, yes, it has access to the digital media company, but sometimes you'll get worse responses from that agent than you would if you just search the web. And it's interesting because you're asking the agent to do a query on the back end, and all of a sudden, like, it could query the wrong things. And then you're telling the person, like, telling the agent, look at this data, we got it for you. This is the golden data. But in reality, maybe like the web search was a little bit more natural and the natural way to search for that document, and that was the right one. So feeding the AI, like, it almost feels like deliberately the wrong information by accident, to me is like a very common problem. And I feel like that's like something that we wrestle with a lot.
Yeah.
But I think hallucinations are harder to solve for sure. Yeah.
All right, we got a minute left on the clock. So rapid fire one. The problems that agents tackle today in enterprises are not the truly hard problems. So the problems agents tackle today in enterprises are not the truly hard problems. Agree or disagree? 3, 2, 1. Ooh, another little opposite here. Any one of you can start.
I think we're like scratching the surface on the problems that were addressed. I am sure that there are some really hard problems that agents are working on in enterprises. I think we're still at the phase where we're experimenting and doing pilots and trying to tackle the low-hanging fruit. But yeah.
I agree. I think we spoke to a bunch of customers who are trying to do some really ambitious things, like building cursor for X. It could be like CAD design or like how do you simulate something, but cursor for that, like they're trying to do something really interesting. It's just really hard.
Yeah. I think I made my opinion pretty clear before. Like I think we want to do like bigger things, harder handoff, long running stuff. So I think a lot of agents these days are like a lot of research read based agents and not write based agents and they're not on critical paths a lot of the time because people haven't really like fully embraced wanting to put it on critical path things. I definitely think there's opportunity to improve.
Thanks for listening to Human in the Loop. To stay in the loop for more AI-related content, make sure to like, comment, and subscribe.